My lit review focused on efficiency improvement options for natural gas power plants and how viable they would be in terms of economic and environmental sustainability. I chose this topic because of the debate surrounding natural gas expansion and figured I should educate myself on the discussion. For those of you that don't know, natural gas forms as decaying organic matter is exposed to high temperature and pressure. This breaks down long carbon chains, reducing it to methane. Fossil fuels release a tremendous amount of heat when combusted, making them an attractive source of energy. Traditional coal plants use the heat generated by combustion to evaporate water which circulates in a different pipeline, as seen in this picture. The steam dramatically increases the pressure in the pipes, causing its rapid movement, which in turn spins the blade of a turbine. The turbine is wrapped in a wire coil and spins within a magnetic field, causing the movement of electrons. This ultimately creates electricity. A big criticism of fossil fuel power plants is that they only operate at about 35% efficiency, meaning that 65% of potential electricity generation is lost. This loss term is quantified by how much heat exits the turbine. The heat that isn't used to spin the turbine just gets expelled from the power plants via the cooling towers. This is called waste heat. There are two main reasons why natural gas has the reputation of being a cleaner fossil fuel than coal. The first is because it releases more heat per unit mass, meaning that you don't have to burn as much of it to extract the same amount of electricity as you do for coal. Natural gas also releases less pollutants, as seen in the graph below. Because more heat is involved, natural gas power plants have an interesting opportunity to convert the waste heat into electricity. The most popular way is to add another thermodynamic system after the first turbine. This is normally either a steam-powered turbine, similar to coal plants, or a gas-powered turbine. By adding another turbine, efficiency ratings improve to about 50 to 60%. Types of power plants that use this method are called combined cycle plants. Currently, a little less than 50% of electricity in the U.S. is generated by coal plants, and about 20% is generated by natural gas plants. Given the current efficiency improvement technologies, there is a lot of room for combined cycle gas plants to expand. Natural gas accessibility has increased fairly dramatically over the past decade. Our planet has some huge natural gas deposits. The most notable lies at the bottom of the ocean as methane clathrates. However, it has been proven to be very difficult to extract. The next most notable deposits are trapped within layers of shale, and extraction technologies are available. The most common way of extracting natural gas from shale is called hydraulic fracturing. Hydrofracking involves drilling down to the gas reserve and then drilling horizontally. A mixture of water and sand is then shot through the rock. The grains of sand create pores within the rock, which allows the gas to flow more freely. Hydrofracking remains a controversial issue. Domestic well contamination is the biggest issue surrounding hydrofracking. Local wells have seen an increase in methane concentration, meaning that methane has somehow migrated up through the shale. This is probably due to leaking joint casings between the pipes or just natural gas migration through the shale. Another issue is simply, should we continue spending money helping the growth of a non-renewable resource? There is literature available that helps diminish the question of water contamination. There have been successful cases of hydrofracking operations where there is very little to no leakage. As long as the companies doing the drilling are cautious not to disturb the geology too much and make sure that the joints are properly sealed, water contamination can be avoided. Perpetuating an economy driven by fossil fuels may be unavoidable if natural gas becomes more widely used. Because more heat is involved, natural gas power plants have an interesting opportunity to convert the waste heat into electricity. The most popular way is to add another thermodynamic system after the first turbine. This is normally either a steam-powered turbine, similar to coal plants, or a gas-powered turbine. By adding another turbine, the main advantage that renewables have over fossil fuels, besides being renewable, is that there are no greenhouse gas emissions. Even though natural gas burns cleaner than coal, there are still emissions. However, natural gas is cheap. The startup cost for building a combined cycle power plant is surprisingly only a little more than a typical coal plant, and marginally less than most renewables. This chart was taken from a Congressional Research Service report and compares how expensive different sources of electricity are. These predictions include fuel costs, operating costs, and include a carbon tax. Not surprisingly, geothermal is significantly cheaper than any other source of electricity. There are no emissions, no fuel costs, and very little maintenance costs. The second cheapest is combined cycle natural gas plants. Nuclear and wind are slightly more expensive than natural gas, and coal and solar are the most expensive. Ideally, for a community to be sustainable, it would need to acquire all of its energy and electricity from renewable resources. Given the current trends in energy demands and fossil fuel availability, it seems that a shift to natural gas and away from coal is inevitable. However, the extent to which natural gas expansion is used in conjunction with renewables remains unknown. Thank you.